you install Docker, three networks are automatically created. They are bridge, host, and none. There are two types of Docker bridges: default bridge and user-defined bridge, which you will learn the differences between the two in this tutorial. Before creating containers, let's get familiarized with our Docker environment by running the following commands as shown: Docker version, Docker images, Docker containers, and take note that there are two ways of showing all containers. And then we will inspect the default bridge to find out its network configuration. As you can see, in the IP Management IPAM section, subnet and gateway were automatically assigned with 172.17.0.0/16 and 172.17.0.1 respectively. We will start with the default bridge, which is used when you don't create a bridge network and you run a container without using the -- network flag. Now let's create two containers named Alpine 1 and Alpine 2 using Alpine image and an -- shell as shown. In the -dit, D stands for detach mode, meaning run the container in the background. INT tells Docker, I want an interactive session with a terminal so I can type commands on the -- shell. Now let's verify the creation of the containers and inspect the default bridge network again and see what has changed. Subnet and gateway are still the same, and two containers were added, where Alpine 1 was automatically given an IP address of 172.17.0.2 and Alpine 2 172.17.0.3. Since both containers are in the same subnet, they should be able to communicate with each other. To verify connectivity, let's get into one of the containers as shown. Use Docker container attach or Docker exec to get into a container. Note that attach is to container and connect is to network. To verify network interface IP settings, run ifconfig or ipaddr show. Verifying connectivity, pinging google.com, default gateway and IP address of the containers work good as shown. Pinging the containers by its name failed because automatic service discovery exists on user-defined but not on default bridge. Let's stop and remove both containers as shown. Then we will move on to configure a user-defined bridge. Verify that both containers were removed. List the networks. And inspect the bridge network to verify containers and assigned IP addresses no longer exist. Create the Alpine-net network. --driver bridge flag is not needed since it's the default, but this example shows how to specify it. List Docker's networks to verify the Alpine-net was created. Inspect the Alpine-net network as shown. Again, subnet and gateway IP addresses were assigned automatically with 172.18.0.0/16 and 172.18.0.1 respectively, and no containers are connected to it. Notice the differences in subnet and gateway IP addresses between default and user-defined bridge. You can conclude that they are separate networks. Now let's create 4 containers as shown. Connect Alpine 1, Alpine 2, and Alpine 4 to the user-defined bridge Alpine-net. Alpine 3 will be connected to the default bridge because the user-defined network Alpine-net was not specified. And lastly, Alpine 4 will also be connected to the default bridge as shown. List all containers to verify 4 containers have been created as shown. Inspect the bridge network and verify that 2 containers were created on default bridge and 3 on the user-defined bridge. Now let's test containers connectivity by attaching to Alpine 1 as shown. Ping Alpine 2, 3 and 4 and to itself. On user-defined networks, like this example Alpine-net, containers not only communicate by IP address, but can also resolve a container name to an IP address. This capability is called automatic service discovery. You won't be able to ping Alpine 3 because Alpine 1, where you are attached to, is in a different bridge network. Even if they belong to the same default bridge network, you cannot ping by name because default bridge network cannot resolve name to IP address. No automatic service discovery. This is the main difference between default bridge and a user-defined bridge. Detach from Alpine 1 by holding down Ctrl and typing P followed by Q. Then attach to Alpine 4. Remember that Alpine 4 is connected to both the default bridge and Alpine-net bridge networks. You should be able to ping all containers attached to user-defined bridge Alpine-net both by name or IP address. However, you will need to ping Alpine 3 by its IP address because it is connected to the default bridge where it does not have automatic service discovery. As a final test, make sure your containers can all connect to the internet by pinging google.com as shown. Detach from the container by holding down Ctrl and typing P followed by Q. Then attach to the next container. As I began to understand Docker networks, the more questions come into my mind like, how do I access containers externally? I found some examples, most of them accessing a web server through ports, so let's try this for now. Download the Nginx Docker image and create a container named docker-nginx. Map the host port 8080 to port 80 of the web server as shown. Test it by accessing the web server from the outside using a web browser as shown. For me to understand Docker's bridge network, I came up with a schematic of this tutorial. The Docker default bridge network is equivalent to my schematic as shown. It has two containers, which is equivalent to two virtual machines or workstations, both in the same subnet. A switch, a dhcp because you're automatically assigned with an IP address, no DNS because you cannot ping by name, a firewall because you can ping from the inside but not from the outside, and you can access application through port mappings, or maybe access control lists like in Cisco firewalls. We'll see as we learn more, and all of these networking capabilities in one workstation. The Docker user-defined bridge is identical to the default bridge. The only difference, it has DNS. Docker calls it automatic service discovery, where you can ping not only by IP addresses, but also by names. For now, my only issue with Docker is the lack of graphical user interface to show all of these networking capabilities like Windows Active Directory users and computers. Docker probably has one like this already, I just need to research it. That's it. See you in my next video.